Hi. In the last video, we are discussed about the basic vector representation and then how to find the distance between the vectors. Some basic things we have discussed. In this video, we are going to see some more advanced concepts like how to representation of plane and how to find the distance from a plane to vector, because finding the distance from the plane to is vector is the most important concept, because we are using this technique in the logistic regression and SVM. These two concepts working based on the finding distance from the plane to vector. That's why it is more important topic. Let's dive into the topic. Let's represent that. How? Let's start with 2D space. In the 2D space, a line represents a plane. Okay, and we generally know the equation of line equation: y equal to mx plus c, or we also rewrite ax plus by plus c equal to 0. Here, instead of x and y, we are used x is equal to x and x1 equal to x and x2 equal to y. Okay, then we will get ax1 b bx2 plus c equal to 0. Okay, now we will represent a and b with w1 and w2 for our convenience. W1 x1, because those are the values only. W2 x2 plus c is represented with w0 equal to 0. Okay, here w0 is the interception value. Now let us see how we can represent a plane in 3D space. Okay, in 3D space, we in the linear algebra we will represent x plus by plus c z plus d equal to 0. Here, instead of we have x1 x2 x3. Okay, and we will rewrite this one: x1 b x2 plus c x3 plus d equal to 0. And for our convenience, we used a as w1, b as w2, c as w3. Okay, and d is w4. Now we will rewrite w1 x1 plus w2 x2 plus w3 x3 plus w4 equal to 0. Sorry, instead of d we are using the w. Sorry for that. And we will rewrite this thing as I equal to 1 to 3, because it is three-dimensional space. Wi xi plus w0 equal to 0. And similarly for n-dimensional space, in the n-dimensional space, a plane is called a hyperplane. For the hyperplane, sigma I equal to n 1 to n wi xi plus w0 equal to 0. Here w0 represent the intersection point. If it is passing through the origin, then this value is going to be 0. Okay, then this value is going to be 0 when it is passing through origin. Now let us consider this is the plane is passing through the origin. Then we will get I equal to 1 to n wi xi equal to 0. And this is a vector and this is also vector. The vector representation in a matrix form, it is like this: w is equal to w1 w2 wi. Similarly, x will be represent x1 x2 so on xn. Okay, and this element wise multiplication is become now a dot product. That means double transpose x equal to 0. Okay, That means we can observe one thing, the dot product equal to 0 means double dot b equal to 0 means modulus of w modulus of b into cos theta equal to 0 means this theta is the 0 value, sorry, 90. I will use this space. When modulus of w modulus of b cos theta equal to 0, then this become cos theta equal to 0, because this is not become 0. Theta equal to 90, then only w dot b equal to 0. Okay, and a plane we can represent with vector w now. We got that thing now. This is a plane, and this plane we can represent with a vector w, and it is perpendicular to the plane at every point. I will rewrite the other things. One second to get. If it is the plane, fine, then the vector representation of the plane we will use w. Okay, and w is the perpendicular to the plane, and for every point in the plane on the plane it is perpendicular. For every point on the plane it is perpendicular, and it is, we will consider generally now we will consider as a origin. Okay, even if it is not origin, we will shift this one to the origin to make it easy. Okay, for suppose if x1 x2, if we have plane like this, then we will shift this coordinate to here to make the plane is passing through origin. This is the one technique we are using generally most of the time to make calculations very easy. Now let us see how to find the distance from a plane to vector. This is the distance that we have to find. Let us call as d. Okay, and we will use blue color. This is the plane, and the vector representation of plane is w, and it is perpendicular to the plane that we can see here. Now let's consider this is the origin. Okay, now let's try the distance. This distance is modulus of p, because the distance from the origin to the point is modulus of p, that we know. This is the distance that we have to find. Okay, let's draw a line, a line to here to here. Okay, this is look like it's a vector, and this is also a vector. It is like look like the projection of point P on W. Similarly, I will show to make clear. And this is a point P, and this is the W. The projection of P on W. It's like a P dot W by modulus of W. This is this distance. Okay. Similarly, here also the distance d equal to W dot P by modulus of W. This is the simplest way. Okay, let's derive basically. Let's derive this thing. Let's discuss the angle between two vectors is theta, and this is the 90 minus theta. Okay, now sine of 90 minus theta equal to opposite side by d by hypotenuse is modulus of p, and this become cos theta equal to d by modulus of p, and cos theta here is, we know, w dot p equal to modulus of W modulus of P cos theta. Cos theta equal to W dot P by modulus of W modulus of P. Now it's become W dot P by modulus of W modulus of P equal to D by modulus of P. S of P modulus of P cancel. D equal to W dot P by modulus of W. This is the same thing that we got. Now this is the plane and this is the vector representation of the plane W, and these are the 2 points. One is the this side and another is this side of the plane. Okay. Now let us find the distance. Okay. For this point the distance D equal to W transpose X by modulus of W. And this distance also it will be same, W transpose X plus modulus of W. This value is positive because this is the same direction to the vector, and this value become negative because it is opposite directions to the point P.